Okay, using the formulas that we've been dealing with, law of sines, law of cosines, they both involve non-right triangles. So the last part of looking at these triangles and where law of sines and cosines can be utilized is finding the area of a non-right triangle. Because if we're given a right triangle, what we know is we have something called the height, we have something called the base, and our area is 1/2 the base times the height. Okay, we know that formula. That's one that we've used this year. So if you have a triangle that's been like this, so far everything we have done in this class, we've been given what the height is, whether it was a dropping in altitude or whether it was a value written out here, and then we'd had the base, and again we could use that same length. All right, but now let's say we don't have a right triangle. All right, so that's where we come up with this next formula. All right, so if we have a triangle, all right, let's call this something like that, and we'll call it triangle A, B, and C. Right, and then we'll say this is lowercase b, lowercase c, and lowercase a. What the area of a triangle, very similar to the law of cosines, all right, but what we're going to say is the area is going to equal 1/2, let's say side B, side C, and then we'll use sine of angle A. Or it's going to be 1/2 side A, side C, multiplied together, just like 1/2 base times height, kind of. But now we would have to do sine of the other angle, or the other side that we didn't use. Or 1/2 side B times side A, and then we would have sine of C. Okay, so notice the two sides that are being given. All right, so if we did B and C, well, the angle that's in between them is what we take the sine of in that formula. If we're given side A and we're given side C, the angle formed between them is the sine of B. If we use side B and side A, the angle formed between them is C. Okay, so not a difficult formula to use, just got to remember it's always the two sides and the angle in between them. Okay, kind of a side angle side sort of thing. So just as a numerical example, let's say this is 3. Let's say this angle right here is 25 degrees. And let's say this is 10. So now our formula for area, and I always write out the word area just because if you use A, it gets confused with the angle of A. But usually the sides don't really matter, all right? Because notice we have our side, we have our angle, and we have our side. So our formula is going to be 1/2 3 times 10 times sine of 25. And then again, it becomes just entering it into your calculator. If you don't want to type in 1/2, you can use 0.5 times 3 times 10, or you can just do 3 times 10 is 30 and divide that by 2, which would be 15. But then when you multiply it by sine of 25, we get a value that becomes 6.34. So our area, 6.34. But again, remember, we don't have a base and we don't have a height. We could say that 3 is the base, but then we wouldn't have this height right here. We don't know what that is. We could say 10 is the base, but then we wouldn't know what this height would be. All right, so those are just two different things within this formula. The only part that makes this formula any difficult to use is, let's say we had this as 10, and we know this angle right here is 120 degrees, and we know this side is we don't know another side, let's say. We're going to do a couple of these. So let's say we know that this is 20. Okay. Well, if we want to find the area of this triangle, we don't have side, angle, side. We have angle, angle, side. Angle, angle, side. All right. If we use the 10, we would need side, angle, side, or side, angle, side. We don't have those. If we wanted to use angle 120, we would need to know these two sides. But this is where the law of sines can come into play, because we have the sine of 120 degrees is to 10 as the sine of 20 is to x. And we'll say x is down here. So we cross multiply and we can solve. And we get 10 sine of 20 is equal to x sine of 120. So now we're going to divide the 120 out so that we can get our side x. All right, we already know 120, 20 is 140, so this angle right here is 40 because angles in a triangle add up to the 180 degrees. All right, so what we have is 10 sine of 20 degrees divided by the sine of 120 degrees, and that makes 3.9. All right, so x equals 3.9. 3.9. Well, now we have a side, an angle, and a side. Okay. I guess if I wanted to use this as my angle in the formula for the side, angle, and the side, I would have had to do this 40 here, and said sine of 40 is to the unknown side. But in any event, we can find the area of the triangle now after we did the law of sines. All right, we now have 1/2 times side 10 times side 3.9 times the sine of 40 degrees. Okay, so we have our two sides. We multiply them together. Again, use 0.5 as the half if you want, times 10 times 3.9 times sine of 40 degrees, and we get an area of 12.5. So 12.5 equals the area of that triangle. Okay. The last one is if you're given all of the sides and you don't have an angle. All right, so let's say this is 5, let's say this is 7, and let's say this is 11. All right, so we have our triangle. We can't do the formula of 1/2, 2 of the sides times the sine of an angle because we don't have an angle. So this is where the law of cosines comes in. So it doesn't matter which angle you find. So if you want to find this angle right here, that works. So what we'll call that is angle x. But remember, law of cosines. The opposite side squared is equal to the adjacent two sides squared minus 2 times those adjacent sides times cosine of the angle opposite the side that we started with. Right, so again, we can subtract the 5 squared and subtract the 7 squared. So that's what I'm going to do. I'm going to do 11 squared minus 5 squared minus 7 squared, which gives me an answer of 47, equals negative 70 cosine of x, because 7 times 5 is 35 times 2 is 70. So I divide by negative 70. So now I wind up with a negative 0.6714, but I have to do inverse cosine. So I have to do second cosine of negative 0.6714 if I round, and that's going to equal my angle x. So I'll press second cosine of that value, and I got a measure for x of 132 degrees. So now I have my angle. So with my formula, I have side, my angle, and my side. So 1/2 of 5, 7, and sine of 132 multiplied together. So 0.5 times 5 times 7 times sine of 132 degrees, and I have an area of 13. 13.01, but we can just round it to 13 for now. Okay, so again, a very simple formula. It's a half, the two sides that you're given that create side, angle, side. And then you just may have to use law of sines, law of cosines, to get all of the missing parts that you need, for whatever the given formula is. Okay, so that'll kind of take our law of sines and cosines into the next phase of using trig and geometry together.